Hey team, welcome back to my channel. In this video, we're going to do some low-level file I/O using the C programming language. And these are the steps I'm going to do. I'm going to include some headers, then I'm going to build a structure. I'm going to use that typedef command, and then I'm going to populate that. I'm going to build some sample data. I'm going to open up a file called data.bin. I'm going to make that for read-write. And I'm going to change the mod on that, which is something cool to know. Then I'm going to write the records to that file. Then I'm going to use lseek. I'm going to go back to the beginning of that file. Then I'm going to loop over that, only read the even records. So I'm going to have to lseek to the correct position, read it, and then print a record. Okay, so let's go ahead and begin. So we're going to begin with some pound include. So we say include stdio.h. Now, if you would, type along with me, okay? So we can do this together. And then pound include standard lib.h. And then we're going to include fcntl.h. And the last one is string.h. All right, cool. So headers, all done. All right, what's next? Build a structure. Okay. Now our struct is pretty cool. So we say struct, and then our fields. So we're going to say int ID, and then char name for 50, and then float a value. And what are we going to call this? We're going to call that my struct. Now, here are some things that I've learned over my career. 50, that's not good. 50 plus 1 is better. Because when I come back in time, I want to make sure that I have allocated that null character to terminate that. So the next one is turn this into a type def. So now I've just defined a new data type called my struct. Pretty cool? Okay, so guess what? Number one's done. Let's keep going. Well, now we're down into main. So we got the return value int, and main is the name of the function, and open close. All right, cool. So now what we're going to do is make an array of these. So you just come down here and what's my data type? Well, my data type is my struct, and I'll just call that data, and I'll put 10 records. Now watch what I do here. I'm going to say int rec size equals size of my struct. And you'll see how I use this later in my program. So my struct is this guy right here, right? You get it. And so populate, okay, I need to populate this array. So I'm going to do that just using a for loop. So for int I is 0, I less than 10, I plus plus, right? And then I'm going to say, okay, so you see this thing is called data. So I say data sub I dot ID equals I. So notice the name of my variable is data, and it's an array. So that's why I have to put these square brackets. I'm starting at 0. ID comes from this guy right here. I think you get it. Now the next thing I want to do is I want to clear out this memory in there, and we're going to use the function called memset. So memset data sub I dot name. Then what are we going to put in there? Well, we're going to put 0, the null character, and then we're going to put 50 plus 1. And then let's go ahead and build a string so I can have a value for name. And why don't we use sprintf? And so what is the name of our variable? Well, that's going to be data sub I dot name. Now what are we going to put in there? Well, let's put in data row %d and then I. Does that make sense? So notice we're looping around that. I'm going to say data row 0, 2, 3, 4, 5. You get it. And now for this last value, why don't notice that is a float? So why don't we do something creative and say data sub I dot value equals 3.141592, how about that, times I. So the first time it'll be 0, and then it'll be just pi, and then times 2 times 3, you get it. Now this is an array, so as soon as I get down to the bottom here, I come back up, I increment I, and now I'm working on the second instance of that. So I just stay inside of this loop until I'm all done. And guess what, you guys? I'm done with 2 and 3. All right, so 4. I have to open up a file. Now we're going to be using, let me put something up here, low-level I/O. Low-level input-output. This is the fastest way you can access files. So notice we're going to say int file descriptor equals open. Now we have to use the name of the file that we want. And how about we call it data.bin. Now, when we open up a file using this command, I have to tell the operating system what kind of access do I want to that. So I'd have to say, let me see, I want to read and write. Does that make sense? And I want you to create that. And the last parameter is, when we get done creating this file, we have to go back to the operating system and give it some permissions. And what I want to do is, for everyone, I want to say 0666. Everybody gets to see my stuff, right? So semicolon. Now, if fd equals -1, well, that's a problem. And why is that a problem? Well, because remember, let me just put a comment in here. So st standard in is 0. Standard out is 1. Standard error is 2. The lowest number this could ever create would be 3. So that's what this number is going to be, is 3. I just thought I would share that with you. So what are we going to do here? So if that is an error, we can use the function p_error and just say error opening file. Exit 1. We're done. Can't continue because something happened with this file. Now, if that file already exists, I'm going to overwrite it. And as I put data in there, down in my code, I'm going to be able to read and write that. Now, if you only make it writable when I'm writing it in there, when we get downstairs and we're trying to read from that, this is going to say, no, I'm not allowing you to read. Okay, cool. So now you've seen that, let me see, open a file. Okay, bang, we're going fast here. Fast and furious, I say. Now, write records to the file. So we have this for loop, and guess what? We're going to do another for loop. I've already got the data, so all I have to do is write it out there. Now watch what I do here. I say for int I is 0, I less than 10, I plus. Okay. Now I'm going to say int the length equals write. Now what's my file handle? It's called fd. And then I'm going to print the ampersand of data sub I. And then I can say, see what I did up here, rec size? All I have to do is say rec size there. Now, the reason why I do this is because I'm going to be doing that a lot. I'd rather not type this. Now I could take this and put that here, right? Take this and put it here, but I'm just showing you the way I program. Now, when I try to write this out, I'm going to get back the number of bytes that I just wrote. Now, if that does not equal this, that's a problem. And if you made this so I could only write to it, that's cool. But if you left off read and write, this is going to be a problem. So just thought I would share that with you. So we're going to say if the length not equal rec size. Now, what does that mean? Well, that means when I wrote that out, got an error. So what are we going to do? Well, we're going to do the same thing, this p_error. So p_error and error writing to the file. Then we're going to close that handle FD, and then I'm going to exit 1. So I'm going to stay inside of this loop for 10 times, and I'm going to use the low-level file IO write command, and notice sub I each time. All right, cool. Now, once I have all that data saved to the disk, now we're going to get on to the next type problem. Now, my file pointer right now is sitting towards the end of that file. And what I want to do is I want to reset my file pointer back to the beginning of that file. So we call that seek to the beginning of the file. So what we can say is lseek fd 0 seek set. And that will get you back to the beginning of the file. Let's put a comment in there. Reposition file pointer to beginning of file. Okay, cool. All right, so we did that. We seek to the beginning of the file. And now I just want to loop over that and print some records for you. So how we do that? So I can show you that this seeking and telling where I'm at, I'm not going to go in order. I'm going to maybe go every other record. How's that sound? So I'm going to say for int I is 0, I is less than 10, I, now watch this, plus equal 2. I'm going to go every other record. Now let's put a little print message in there. So printf, let's search for the record %d at position %d, new line. Okay, so in this first placeholder, we're going to print I. So let's do that. Now, how do I get the position? Well, the position will be known by the function tell. So all I have to do to get the position of that is just say tell the file handle. So it's fd. So we get a nice little message that says, okay, I'm searching for record 0, and that is at position 0. Now when I come around and get the next record, I'm plussing it by 2. So this will be, I'm getting record 2 at position, and then it'll tell me where I'm at. Now it's going to offset because when we do the read command, the offset changes. And let's spell this right, that's FD. Okay, cool. So I just showed you a little message there, and now I'm going to say int offset equals I times rec size. And then I'm going to say int position equals lseek, the file descriptor, the offset, and then seek set. So this is me dynamically moving around inside of this file. That makes sense? Now, once I reposition position, it is possible here that I don't go to where I want. So I have an error. So if position, let's get in the right case here, guy. If position equals -1, that means I got a boo-boo. What are we going to do? We're going to print error. We have like an error now. So p error seeking inside of file. Close FD and then exit 1. All right, cool. So you see here, I'm going to print a message out. I'm going to build this offset. I'm going to try to seek to that offset. If I get into an error, I'm going to get out there. Now, once I I get there, guess what? We're ready to read. We're going to make this happen. Now watch what I do here. So my struct, remember I used type def. So this is a type now. And I'm going to say temp record. So int bytes read equals read FD, the address of temp record, and then rec size. So I reposition where I wanted to read from, and then I'm going to read that file handle. I'm calling it FD is my variable name. I have a new variable here, and I'm going to read for however big this record is up there. I believe it's 60 bytes. So I'm going to read 60 bytes, and it's going to look like this right here. Okay, cool. You know it. This could not be this size. This should be this size, but if we have an error, we gotta do something for that. So we're going to say if bytes read not equal the rec size, what are we going to do? Well, we're going to do that p error again. P error reading. We're going to close FD and then exit. All right, you guys, we are at our last little thing I told you I was going to do here. I was going to loop over file, only get even records, print records. Okay, so all I have to do is to print the records now. We're done. So we're going to use that printf function. So printf record, and we'll go %d, that's a placeholder, new line, and then we'll put I in there. And then we'll say printf ID %d, new line. Now what will that equal? That will equal temp record .id. So remember, our source when we were making a file was data, and I use that just to write out to the file. Now I'm showing you I can read from the file, and I'm just using a different variable name now, temp record. I'm getting one record at a time. Up here I had an array of those. Down here I just have just one. Okay, so now the second one was name, the third one was value, and so this is going to be name and value. Okay, so then I come up here, I get the next record, see that 4, I reposition it again, and then I just stay inside of here and I'm printing every other record. Now, when I'm at the bottom of my program, what I want to do for sure is every time you open a file, you have to close it. So we're going to say close FD and then return 0 to the operating system. Now I'm using return 0 because up here at main, notice I'm saying int. So if this program is running from a batch file, it will get a 0. Okay, does that make sense? All right, cool. So let's turn that into an S because we have a string here. So let's compile this and run it. Let's see how that works. So notice we just have our one file in here. Here's the source code. And to compile that, all you say is gcc, and then the name of our program is called lowio.c -out for output, and then lowio.exe. And then to execute that, you just say lowio, and notice the output went to the screen like we designed. Notice 0, 2, 4, so our skipping works. Skipping works, that means our else set was working, right? Got this value because we know how to do the function tell. So all of that stuff is working fine. Let's take a look at this directory. And there's our file, data.bin. Now if I say vi data.bin, well, is binary, right? So that has all our data in it. And there you have it, team. If you have any questions or comments about this program, please leave them below in the comments section. Hope you enjoyed this video. Look forward to seeing you back in my next video. Take care.